Hello everyone, I'm Renaldi, and I'm going to be giving a talk, The Many Faces of Mutability. I hope everyone's having a great time so far at the conference, as I'm sure that every one of these talks have been very insightful. I'd also like to give a big thanks to the Belpie committee for having me deliver my talk. So without further ado, let's get straight into it. So first off, we need to first get a good understanding of mutability. As I'm sure that everyone here is already very frequent Python users, at one point or another, even if you're a beginner, you'll probably already have stumbled upon mutability, as well as, of course, the consequences that come along it. Sometimes we question ourselves, how can we really utilize it well? We knew there's mutable objects, which are changeable after object is created, and immutable objects, which are changeable after object is created. However, the real headache often comes along when you start to actually experiment with mutability. So I drew up this particular diagram and example. So for example, we have like A and B. Our intended behavior is essentially to only change A, although they technically refer to the same block. And that's why I represented all these as blocks, essentially as addresses. And essentially what we want to get out of it is A to be changed because we want it to be added to C. So we want the end result to be added to AC, but sometimes we end up actually also altering B, which is not the case in this picture because we want A to be AC but B to be A only, essentially unchanged because we only want to change A. But oftentimes, when we deal with mutability, we end up changing both of them. And we're going to be going in deep into why that happens and methods onto how we are able to eventually get over it and how we can eventually use mutability for good instead of course, for the more consequential reasons that will actually end up in if we continue on using it in the wrong way. So, what is the problem? It's simple, but it's misleading. Really, that's mutability in a nutshell, really, because oftentimes we really just want to do something small, but in the end we end up changing a lot more than that, because mutability it's a pretty interesting thing, really, but it's something that we always need to consider when we do. And of course, we also have to consider for the possibility of bugs that can happen, because essentially mutability is always a thing that you often encounter, and essentially there are so many chances that you can actually get bugs from that. So that's why we have to consider all the consequences of mutability. Now, let's look at one particular problem, shared references. In this particular code, you can see that I initialize a new list. And of course, and just an empty list, a list within the list, and just add 10 of them. So as you can see, we initialize 10 different empty lists within the list. Then we choose to append new list, and of course, we choose to insert at the fifth list, at the fifth position, which is essentially the sixth position, and we append number 2 to it. Sounds good, right? However, we end up with this in the end. We end up with a whole list of 2's in the end. And why is that so? Now, this is going to be very interesting because essentially, what we do here is essentially we are appending to the default argument, essentially, of the new list. Because default arguments and the argument trying to append it itself is always a big problem within these kinds of scenarios. With mutability, default argument is always usually a pain because it ends up actually initializing it to every one of them, essentially because default argument considers it as sharing the same address, and this is why it happens. And I'm going to be talking a bit about how we can avoid these problems over the next few slides. When we talk about mutability, we need to be able to get a balance between simplicity and helpfulness, because oftentimes, as seen by the shared reference problems, things that can be too simple, such as this, often lead to bad things. Because, of course, it looks simple, right? It's just a few lines of code. But in the end, it ends up actually getting the wrong kind of idea. It ends up actually initializing to the whole list. So, when we code as well, we need to be able to make sure that our code is clear and concise, not only for developer experience, not only for people to be able to understand your code better, but also to be able to really understand what your code is doing and to be able to ensure that there is no holes for mutability problems. Now, between the first and the second picture, there's basically a code showing a similar functionality. Essentially, what we want to do is to insert content and essentially insert a category in this particular case. So essentially, we're essentially appending content. So in the first case, we can see that we are essentially defining insert content as a particular function. We append the content, and of course, just a typical insert content in the end for our function. And of course, for the second one, we instead initialize a list. And now we actually have a separate thing. So we essentially initialize a list, we append to the list, and we return a category. And of course, for our second function as well, we initialize category to insert content, and we pass in action as the particular category, and we also put in the list. So, which is better in your opinion? Now, oftentimes I actually get a lot of responses to people saying that, you should always pick the simplest thing because it makes things much simpler instead of the more verbose kind of thing. I'd like to disagree with this point because I believe that sometimes more detail is better than too simple. And this is why I am insisting on really putting more detail, especially when we deal with stuff like mutability. We often deal with stuff like this. So we need to be able to pick the more verbose stuff to be able to really put more detail in. So, because in this case, we're specifying particularly what list we're appending to. Whereas, in the particular insert content, we are basically just inserting content as a particular case, and we're already putting it just like that, and essentially we're not putting in a second argument, but we can directly specify like which list we want to put it to, and this is essentially the pitfall of where a lot of where mutability trapped a lot of people as well, because we don't specify particularly, and if you don't specify, it ends up assuming oftentimes that you want to put a list of its assumptions. So essentially, that's where a lot of problems of mutability rise up. So, well, that was a good solution. So essentially, the problem is, can we just spot it and end the problem? And of course, then again, it depends with the use case. So not all use cases are the same. This one in particular is a much simpler problem because we can directly spot the problem and we can easily put a more verbose solution. However, there are problems that are not too simple. And essentially that's where we need to be able to think up of solutions along the way and essentially test along the way as well. And really to be able to figure out which one we can really take up and really modify alongside it. Of course, afterwards, we also have the problem of coding with user experience, and of course, because we need to be able to code with considering what our fellow developers actually need, and can they actually understand our code well. And of course, coding with this in mind will help a lot with this. And of course, think of it as well of how other people will understand your code and how you would too, because you need to be able to understand the code well. Let's say if you actually come back to the code, say in 3 months, can you actually still remember what's happening? Or 6 months, can you still remember what's happening? And of course, because we move on to so many products from day to day, sometimes we end up actually not being able to address the particular issues, and we go back to it at another time. And will you still remember it at that time? And is your code easy enough to understand for you to get back to quickly? So that's all about essentially also about mutability, because mutability is all about modifying behavior, and really it's all about understanding quickly where to be able to modify your code, because just one particular chunk of code that goes awry can really affect a lot of code. That's essentially the pitfalls of mutability, and that's why it's pretty crucial for us to be able to understand how to be able to use it well. And here we have the pain of default arguments. We're highlighting it even more essentially. So essentially in this particular case, we're essentially defining a particular function called argtest. We have item 1 and item 2 declared as a list. So essentially we want to be able to append whatever we pass in as item 1 to the item 2 list. So we then return item 2. So as you can see, we have an interesting behavior here. So we first call our arc test and we insert the number 8. Still same, and we insert it a second time again, so we have 8, 8. That's still good, right? Things get interesting when we start actually trying to append to a particular list that we declare. So let's say we have a list of 8, 9 item, as you can see over there, and we append 5 into it, and we have now we have 8, 9, 5, as expected, right? Then we pass in our test 8. Then the list completely changes back to 8, 8, 8. And of course, why is this so? The answer is simple, really. Default arguments. As mentioned before, default arguments are a big pain within beginning developers especially, because oftentimes we are led astray with its behavior. So as you can see over here in this case scenario, we have 888, and this is because essentially the initial list that we are actually appending to essentially the default list itself. And that's why when we append to 8, we don't essentially append to the list that we declared before. We're appending to the default arguments that's essentially declared before as part of the default kind of list. So when we try again, of course, when we, for example, do arc test and default and take 0 as the index, essentially we also get the same behavior. We're essentially targeting it to the same address. And we are appending 2, and as you can see, we append 2, it successfully appends 2 in the end, and when we try to append 2 again, it still adds to the same list. So that's one thing to watch out about default arguments, because basically it's essentially a different kind of list, because it's essentially the default list that's set up. So we need to be able to append it carefully. So how do we use it properly? Of course, all of this always needs a good example. So in this particular case, essentially, I'm defining a particular case again of appending to an element to an item. So what we want to do is append to an element to a particular item list, and we then want to be able to return a particular new item list. And essentially, in this particular case, we have list 1, and then we start to append element, and we append item 1, and we then want to print list, and in that case we start to be able to print each of these lists. So our expected case scenario would be that essentially that item 1 would be separate from the second one. So essentially what we want to get from list 1 essentially just item 1, and from list 2 we want to be able to get item 1 and item 2, right? But in reality, essentially, that's what we will get in the end. But essentially, what we want is essentially item 1 and item 2 separately, because we're depending into different lists, right? We want it to be able to be appended to different lists. So essentially, the behavior will instead cause item 1 and item 2 to be combined by the time we actually print list 2. And essentially, this is also because of default arguments again. Now, how we can combat this is by actually assigning a particular default argument, in this case, using none. So, as you can see in the function on the right, we can actually do this. We can actually append a particular element. We append an element, we then assign an item to none as the particular default argument. So then we check. If the item is actually none, then we can actually just initialize an empty list, and we can just append the element to it. And this is a great way of actually combating default arguments, because we can essentially use none as a particular way to check if the particular argument is as part of the default. If not, then we can just add on to it. So this essentially will help us to be able to separate between these particular case scenarios as opposed to the first one, which it didn't really allow us to actually separate well and consider that we were appending to the same list. And next, I'm going to talk about memoization. Memoization is a very interesting technique, and in case you didn't know it yet, it's essentially an optimization technique used primarily to speed up computer programs by storing results of expensive function calls, and essentially it helps you return the cached result when the same inputs occur again. So in this particular case scenario, we're essentially putting in a particular diction as a particular dictionary list. So what we do here, essentially, we're essentially defining memoize. We're doing essentially checking if it is in diction or not, and essentially if it's currently not in diction, then we will essentially execute the memoization. So then we can be able to return the particular diction. And of course, in memoization, we need to always be able to choose the more efficient approach. In this particular example, we have two particular cases. We have a case where you actually store locally and be able to actually take from the local cache, which is evidenced by the first one, the first case. Or you actually want to store it in a dictionary first, and actually you want to be able to check for the memoization result within the dictionary, as evidenced by the second picture. So essentially, the first one works much better in this case scenario because essentially local caches are just much faster. So even in memoization, we need to always be able to consider which is the most efficient method we take within this particular case scenario. And memoization is very powerful too in Mutability because we are able to directly get what has changed, and we are able to directly get accordingly. And with try and accept key error, we are able to also directly use it as a tool to be able to help us cache results and get them accordingly. And next, I'm going to talk about dependency. Dependency is also another big feature and also downside of Mutability because oftentimes we can actually initialize the list, let's say to call, and essentially we may actually declare a particular class as, let's say, register func. And we are playing a decorator pattern here. We're essentially defining a register callable method. We're essentially using self-callable, and we're using toCall that append toCall, and essentially we're returning the particular toCall method. We then actually call def callable. We then have call to self, and we call the arguments as well. We then actually call the original call method again, and afterwards we're able to essentially get the register function, and with this we add functionality to the particular function. So this is particularly a consequential of a dependency that we can actually use properly to be able to consider arguments that are inputted into it. And I'd like to briefly introduce ICE, which is a roadmap for checking proper Mutability usage. And essentially it's identify, create, examine. So firstly, we identify which elements are likely to include Mutability or immutability. We then create classes on what is identified, and we check that all classes and code work overall as identified. And that helps a lot with the overall planning for Mutability usage. And briefly, use case. I've used it before for implementing a Mutability for hash tables to store records of data within my own personal work purposes, and it's an example of what we can use it for. We can use it essentially to be able to add self ID, name, account type, and essentially use a hash table to store these information, call it. So to sum up, Mutability can be your friend. It's rare that you can actually mess up with default arguments that gets you places, essentially when you actually use it right, and utilize it in methods such as memoization and also others to help you on your journey. So thank you, and feel free to connect with me. If you have any questions, I'll be happy to answer them.